Hello, my dear students. This is again Teacher Jenny guiding you to the fourth module of Quarter 3 in Mathematics 8 with the topic Postulates on Triangle Congruence. With the learning competency, illustrate the SAS, ASA, and SSS congruence postulates. But before we proceed to the lesson, can you still remember this statement? Two triangles are congruent if their vertices can be paired so that corresponding sides are congruent and corresponding angles are congruent. Where was this statement taken? Very good. It's from the CPCTC, or the corresponding parts of congruent triangles are congruent. So for this CPCTC, it was stated that we can only prove that two triangles are congruent if all the 6 corresponding parts are congruent. Let us have an example. We have here two triangles, triangle BET and triangle YOU. So to prove that these two triangles are congruent, there must be 6 pairs of corresponding parts. Now let us identify the 3 corresponding angles. Using the tick marks, we have angle E is congruent to angle Y, the angles with 1 tick mark. And for those with 2 tick marks, we have angle T and angle O. For the 3 tick marks, we have angle B and angle U. For the sides, we have side ET is congruent to side YO with 3 tick marks. Next, we have side TB and side OU with 1 tick mark. And of course, we have side EB and side YU with 2 tick marks. So since we have enumerated all the corresponding parts, we can now say that the two triangles are congruent. So we have triangle ETB is congruent to triangle YOU. Now what if there are only 3 given corresponding parts like this? So given here are only the 3 corresponding sides. Can we still prove the triangle ETB is congruent to triangle YOU given only the 3 corresponding parts? Okay, not by CPCTC, but using the triangle congruence postulates and theorem. Because for this triangle congruence postulates and theorem, there will only be 3 congruent parts to be needed in order for us to prove that two triangles are congruent. But before we have these different triangle congruence postulates, let's have first the included side and included angle. Starting off with the included angle. When we say included angle, it's the angle between the two sides of a triangle. Say, for example, in here, we have what is the included angle between segment MN and segment ME. So if we're going to take a look at the figure, segment MN is here and segment ME is here. The included angle is the angle formed by those two given segments. So the angle is angle EMN, or simply it's angle M. Next, what is the included angle between segment EN and segment ME? Okay, segment EN is here. Segment ME is here. So the included angle is angle E. Have you noticed the pattern? Can you name the included angle even without the figure? Okay. The vertex is simply the common letter on the name of those two given segments. So in here, segment EN and segment ME, the common letter or the common point is E. Therefore, E is the vertex of the included angle between those two segments. Last example for included angle. What is the included angle between segment EN and segment MN? Very good. It's angle N. Let us see. EN is here. MN is this one. So the included angle is this angle because it is formed by those two given segments. So we have angle N. So that's all about the included angle. Next, we proceed to the included side. What is the included side between angle M and angle E? For included side, it is the side common to the given two angles. So angle M is here, formed by side EM and side MN. And angle E is here, formed by segment ME and segment NE. So what's the common side? Of course, it's side or segment ME. Next, what is the included side between angle E and angle N? Very good. It's side EN or segment EN. So we have here angle E, then this is angle N. So the included side is the side between those two angles or the side common to those two angles. So that's side EN or segment EN. Now, have you noticed how to find for the included side even without the figure? All right, you simply have to get the vertices of those two given angles. Now, since the two angles are named using the vertex, then we just have to combine those two vertices. So we have segment EN. Now, how about this last example? What is the included side between angle M and angle N? Correct. That's segment MN. Because angle M is here and angle N is here. So the included side is between them. That's side MN. Now, don't forget this included side and included angle because you will be using them in the different triangle congruence postulates and theorem. Let's have now the first triangle congruence postulate. We have the SAS. SAS stands for side, angle, side. Take note, angle is between the two sides. Therefore, for SAS postulate, it states that if the two sides and an included angle of one triangle are congruent to the corresponding two sides and the included angle of another triangle, then the triangles are congruent. In figure, we have this one. So as you can see here, there are two pairs of congruent sides and then one pair of congruent angles. But take note, the angles are the included angle of the two given congruent sides. Now, if that angle is not on the included side, then we can use the SAS postulate. Okay, let us have examples. Given here are the three corresponding congruent parts of two triangles. Using only these three congruent parts, can we prove that the two triangles are congruent using the SAS postulate? How did you know that? Okay, let us see. So first, since it's SAS postulate, so two sides should be given. So we have these two pairs of congruent sides and one angle. So we have this one. Now let us see if the given angle is the included angle between those two given sides. MR and ME, so the included angle is angle M. That's right. Segment TN and segment TI, so the included angle is angle T. So this is also correct. So that means this is a pair of the included angles. So you're right. The two triangles in this first example are congruent based on the SAS congruence postulate. Let us have another example. Again, given these three corresponding parts of two triangles, can we prove that those triangles are congruent based on the SAS postulate? Very good, we cannot. It's because the given pair of angles are not the included angle. You're right. So for the first triangle, since the given sides are segment HN and segment ON, that means the included angle should be angle N. For the second triangle, we have segment ST and segment ET. So the included angle should be angle T. Very good. So since the given pair of angles are not the included angles, then we cannot prove that the two triangles are congruent based on the SAS postulate. Next example, we have this figure. So in here, we have two triangles connected by one vertex. It's at this point. Now, can we prove that these two triangles are congruent using the SAS postulate? Okay, let us see. So to have the SAS postulate, there must be two corresponding congruent sides. We have this one and this one. That's the first pair. Second pair is the sides with one tick mark. We have this one. Plus the third corresponding part should be the included angle. So we must have these two angles here, this one and this one. But take note, they are not marked to be congruent. Since we need that to prove that the two triangles are congruent using the SAS postulate, what do you think can be used to prove that these two angles are congruent? Very good. It's by the theorem, vertical angles are congruent. So since these two angles are vertical angles, then they are congruent. So with that, we already have two pairs of sides. So with that, we already have two pairs of corresponding congruent sides and a pair of congruent angle. And those angles and a pair of congruent angles. And those angles are the included angles of the two given pairs of congruent sides. Therefore, with that, we can now prove that the two triangles are congruent using the SAS postulate. Let's now have the second triangle congruence postulate. We have the ASA, or the angle-side-angle congruence postulate, which states that if the two angles in an included side of one triangle are congruent to the corresponding two angles in an included side of another triangle, then the triangles are congruent. So for the ASA congruence postulate, we have this figure. So in here, we have two triangles, triangle MIZ and triangle YOU. So observe that there are two pairs of corresponding congruent angles. Angle I and angle O with one tick mark, and angle Z and angle U with two tick marks. And for the included side, we have here, so for the first triangle, since the given angles are angle I and angle Z, so the included side is segment IZ. And for the second triangle, we have angle O and angle U. Therefore, the included side is side OU. So with ASA congruence postulate, we can now prove that those two triangles are congruent. ASA, angle, included side, and another angle. Let us have more examples. Given these three corresponding parts of two triangles, can we prove that those triangles are congruent based on the ASA congruence postulate? Okay, let us see. So first, we have to determine first if there are two pairs of congruent angles and one included side. So as you can see, there are two pairs of corresponding congruent angles and one side. Now let us see if those sides given are the included sides of the given angles. For the first triangle, we have angle M and angle MOD. Take note, if the angle is named using three letters, the vertex is the middle letter. So we have side MO or segment MO. For the second triangle, we have segment UL. So since these two sides are the included angles, then we can say that the two triangles are congruent based on the ASA congruence postulate. Let us have another example. So again, given these three corresponding parts of two triangles, can we prove that those triangles are congruent based on the SAS congruence postulate? Very good. Because we have here two pairs of congruent angles and a pair of congruent sides. And those pair of congruent sides are the included angle, and those two pairs of congruent sides are the included sides of the given angles. So for angle S and angle D, that's segment SD. Angle J and angle Y, we have side JY. Last example. So given these figures, can we say that those two triangles are congruent based on ASA congruence postulate? Okay, it's a yes. Because we have here two pairs of congruent angles and a pair of included sides. So that's all about the ASA congruence postulate. Now let's have the third congruence postulate. We have the SSS, or the side-side-side congruence postulate, which states that if the three sides of one triangle are congruent to the three sides of another triangle, then the triangles are congruent. So that is when we can prove that all the sides of those two triangles are congruent. Let us have examples. Now, given these three corresponding parts of two triangles, can we prove that those triangles are congruent based on the SSS congruence postulate? Very good. It's a yes, because given here are the three pairs of corresponding congruent sides of two triangles. How about in this example? Given the three corresponding parts, can we prove that the two triangles are congruent based on the SSS congruence postulate? Very good. Obviously, we cannot because the three given corresponding parts are the angles and not the sides. How about in this example? There are two triangles here connected by one common side. Can we prove that these two triangles are congruent? Yes, you're right. We already have here two marked congruent sides. We only need one more, and that side is this one. Since it is already the common side between those two angles, then this is obviously the third pair of corresponding congruent part. This side is congruent to itself by reflexive property. So those are the three triangle congruence postulates. We also have one triangle congruence theorem, and that is the AAS congruence theorem or the angle-angle side congruence theorem. Take note, if you're going to compare it with ASA, in ASA, the side is between those two angles. That's why it's the included side. But for this AAS theorem, the letter S is at the end. That means the side is not the included side. So it states that if the two angles and a non-included side of one triangle are congruent to the corresponding two angles and a non-included side of another triangle, then the triangles are congruent. In the figure, we have this one. So there are two triangles here. Given as marked, there are two corresponding congruent angles and a pair of corresponding congruent side. But those sides are not the included sides. So given two angles in a triangle, there are two non-included sides that we can use. So since in here we have angle A and angle LA, so there are the two non-included sides are side AD and side DL. For this second triangle, we can have side EG or side EN. So we can have these two. So that's for the AAS congruence theorem. Let's have examples. Given these three corresponding parts of two triangles, can we prove that these triangles are congruent based on the AAS congruence theorem? Okay, let us see. So we have here angle A and angle N. So the included side should be side AN. But since the given segment is not AN, then it's not the included angle. So we can have this one. For the second triangle, we have angle W and angle R. So the included angle should be side WR. But since the given side is side RE, that means it's not the included side. So with that, we can say that the two triangles are congruent based on the AAS congruence theorem. Let's have another example. Again, given these three corresponding parts of two triangle, can we prove that those triangles are congruent based on the AAS congruence theorem? Very good. No, we cannot prove the congruency of those two triangles using the AAS congruence theorem because the given pair of sides are the included sides. And for the AAS, it should be the non-included sides because we have here angle A and angle D, and we have side AD. Angle H and angle U, we have side UH. So instead of the AAS congruence theorem, what postulate can we use to prove the two triangles here? To prove that the two triangles here are congruent? Very good. It must be the ASA congruence postulate. Last example. Given here are two triangles. Using the marked congruent parts, can we prove that those two triangles are congruent using the AAS congruence theorem? Very good. It's a yes because there are two pairs of congruent angles and a pair of non-included side. So those are the triangle congruence postulates and theorem. So before we end, let us first recall what we have discussed. We can prove that two triangles are congruent given only three congruent parts. It's by the use of the different triangle congruence postulates and theorem. There are three triangle congruence postulates. We have the SAS or the side angle side postulate, the ASA or the angle side angle postulate, the SSS or the side 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 postulate, and one triangle congruence theorem is the AAS or the angle angle side theorem. That's all. Thank you for watching. Goodbye.